So up till now, we've learned how to create objects. So in the past, we've created a dog object, we've created a point object, we've created a line object, and we've created many other objects in the previous examples and videos. And how do we create an object? We create an object from a class. We first write a class. So for example, for the dog object, we wrote a dog class. We give the dog some attributes, for example, name and age. We create a dog constructor, and we create some methods, for example, bark. And so once we have dog class, from here we can create as many dog objects as we want. So what are the different parts of this class? You can say that this has three parts. The first part is what the object has. This third part is what the object can do. And this part is how to create the object. So every object has some attributes, and these are the attributes. That is why we specified this as what the object has. The second part is the constructor. And using the constructor, we create an object. So that is why we said that this is how to create the object. And the third part is what the object can do, the different methods that it can have, or the abilities that it might have. That's why we said that this is what the object can do. And there can be many different methods. The object can do a lot of different things. So this is how we create an object. At first, we write a class. We have a part where we specify what the object has, and then we specify how the object is created, and then we specify what the object can do. And once we have the class, we can create objects from this class. And that is what we've learned up till now. We've learned how to create objects. So object-oriented programming is basically all about creating objects, and those objects would then interact with each other. They would give different types of outputs, and a lot of different objects will be able to do a lot of different things. And that's how a software is really created, using an object-oriented programming paradigm. A simple example is when we created the point and the line class. You would remember that we used the point object in the line class. So different objects can interact with each other in this way. And so you can create more and more complicated programs. And this is what object-oriented programming is. You create a lot of different objects which interact with each other and ultimately give you different results. So now we know how to create simple objects. Some of those objects might interact with each other, just like we saw in the line and point example, where point was a part of the line class. But when you have a huge program and you're creating a lot of different objects, there are four very important concepts that we always need to keep in mind. Those four concepts are the foundation of object-oriented programming. And those concepts are encapsulation, inheritance, abstraction, and polymorphism. They might seem like very complicated words, but once we go through the concepts and really understand what they're trying to achieve, you'll see that they're not that complicated and that they're very simple concepts. Today, we'll talk about encapsulation. If we make sure that we follow each of these concepts while designing our programs and while writing our code, while creating our objects, then our programs would be really robust and efficient. So let's dive into encapsulation and see what that is all about. So think of it like a capsule. Whatever you want to put in the capsule, put it in and then seal it shut. That's what encapsulation means. You put something in the capsule and then you shut it, making sure that it's airtight. So if we really think about it, if we are to make sure that we encapsulate something, let's say, for example, this medicine capsule, whatever medicine we want to put in the capsule, we put it in and then seal it shut, right? So there are some things that we need to be careful about. We need to make sure that all of the medicine and everything related to it is in there, right? So that would be one of our conditions, that we put everything related to an object in one container, right? Just like we're putting everything related to the medicine inside this capsule. In the same way, we need to put everything related to an object in one container, and only one container. Secondly, we need to make sure that no one from the outside of the container can tell how things are working inside the container. Or we also don't want them to make any unwanted changes to the contents of the container, right? And three, we need to make sure that the container does not leak. Now, how does this work for object-oriented programming? So think of any object. Let's say, again, the dog object that we were talking about. Everything related to the dog object, we need to put in one container. And that container was the class. We put everything that the dog has, all of its attributes, in the class. We put how to create the dog in the class. And we also put all the abilities of the dog, what the dog can do. We put all of that in the class as well. So everything related to the dog was put in the class, and the class is our container. So if the class is our container, then we need to make sure that no one from the outside of the class can tell how things are working inside the class. We don't want anyone from the outside of the class to make any unwanted changes to the things that are inside the class, right? And for object-oriented programming, the way we do it is by using getters and setter methods and method logic. We'll see what getters and setters are, but what method logic means here is that from the outside of the class, you only call the method and use it. From the outside of the class, you cannot really tell how the method logic works. Whichever method you're using, exactly how it gives you the result, you do not know from outside of the class. So just by keeping the method logic inside the class, we make sure that how the different parts of the class are working are hidden away. And so no one from the outside of the class can tell how things are working inside the class, how the methods are giving you results from inside the class. And thirdly, we want to make sure that the container does not leak, which means that we don't want any information about the variables to be exposed outside of the class. But if we do want to expose them, we want to control that exposure. We want to control exactly how those variables are accessed and manipulated. And for that, we use access modifiers. And we've already learned what access modifiers are in the previous videos. So let's think of an example. Let's say we're creating a class for person. So we have a person class. We want to create person objects. The person can have a few attributes, so we'll just talk about two. Let's say the name and the gender. So we've defined the attributes, what the person has, and every person object will have a name and a gender. Great, now we create the constructor. The constructor has the same name as the class, and it takes the name and gender as input. And then let's say the person has the ability to talk. String is the return type, the name of the method is talk, and let's say it just returns the word hello. So this is our person class. You see, everything related to a person that we wanted to define is within this container, and the container is the class itself. We wanted the person to have a name and a gender. We have defined it here. We also have defined exactly how to create a person, and we have defined what the person can do. We have done all of that in one container, and that is the class. So the class is our container. The class is our capsule. Now let's say we go outside of the capsule. We go in the outside world, and we go into the main class. Let's say in the main class, we have the main method. The main method is always public. It's always static. It does not return anything, so it's a void. The name of the method is main, and it can take some arguments, but we have not discussed that, so don't worry about it. Okay, now let's say we want to create a person object in our main class. So now we've created our person, P1, and P1 person's name is John, and P1 person's gender is male. So I'm sure you remember that John basically comes here, and this dot name is basically this name, and then this name here is basically this name. So we are assigning the value John to this variable here, ultimately. In the same way, the string male comes here, and then this variable here is the same as this one. This variable here is the same as this one. And we're saying that both of these are equal, which means that we're assigning male to the gender variable for P1. So that is basically how the constructor works, and you already know it from the previous videos. I just thought I should repeat it here. But now we have our person P1. So for person P1, the name is John and the gender is male. That's the value stored in these two variables for P1. But the main class's object P1 has direct access to these variables. How? You see, if we write P1.gender, this means that we're directly able to access this variable. And if we then say P1.gender equals, let's say, pizza, if we do this, then because we have access to this variable here, you see we don't have any modifiers here. So because this variable is now accessible, we can access it. We can just change the gender's value to pizza. And what would happen? The gender's value would now become pizza. So this is an unwanted change. We don't want this to happen. We do not want anyone from the outside to change our variables any way they want. We need to stop that. So how do we stop this? How do we stop this leaking? We make sure that these variables are not accessible anywhere outside of the class. So we make them private. So now both our variables name and gender are private, which means we cannot access this. And this will actually give us an error now. Previously, this was running and our value was actually getting changed. But now this would give us an error and it would say that you cannot change this value. But we do want to allow some access because we want to be able to use these objects and manipulate them, but in a safe way, right? So instead of allowing direct access, like we were doing before, we made sure that they're private. Now there is no direct access because private keyword basically makes these variables only accessible in the class. They are not accessible outside the class. But how do we give access to these variables? They're private now. We do them by using getters and setter methods. So they're just methods, exactly like talk is a method. But we use that to get the value of these variables and set the value of these variables when we need to. And that gives us more control. How so? Let's see. The methods are usually public because we want the objects to be able to use the methods, right? So we usually say that they are public. So we'll have a public getter method, let's say for gender. So a getter method for every variable starts with the word get and then the variable. So a getter method for gender would be get gender. A setter method for gender would be set gender. In the same way, a getter method for name would be get name, and a setter method for name would be set name. So because we're trying to create a getter method for gender, we would say get gender. Of course, we have to provide the return type as string here because gender is string. And when we're getting gender, we're returning the value of gender, which is a string. So we should specify that the return type would be a string here. And here we would just return the value of gender. So now, if you want to know the value of gender, you do not directly access it. You access it using this method. And so you do not have direct access to the variable. You can just ask what its value is, and this method will return the value. In this way, we are protecting our variable. We are encapsulating it. Let's create the setter method for gender. The setter method will not have any return because we're just setting the value and not really asking any value to be returned. So this will be void as the return type. We would say set gender. And of course, if you're setting a value, it will take a parameter input. So we would say string new gender. And then we'll set this new gender as the value of this gender. And how do we refer to this gender? We use the this keyword, right? Because this gender is the instance variable. So we refer to instance variables with the keyword this. So we would say this.gender, which means this variable here will now become whatever the input was, which was new gender. And so now we have a getter method and a setter method for gender. This has a few problems and we will discuss it. But right now, this example was only given to you just so that you understand what a getter method and a setter method is. So now that these are private, of course, this line, this statement here will not work. So let's remove that. All right, so now you understand that we are encapsulating everything regarding an object in classes, and classes are containers. And you also understand how we can prevent unwanted changes using getters and setter methods. So for method logic, think of using the method talk. So we can say p1.talk, and this would return a string hello. But from the outside, let's say you're not looking into the container. From the outside of this container, can you really tell what's going on here? No, you just use it and you get a result saying hello. And so how the result is being calculated and what's happening inside this is completely hidden away inside this container. Outside of this container, nobody knows how this method is working. Nobody knows how this hello is coming about. Anything can happen here. This method can have a lot of other statements that do a lot of things. But ultimately, if the result is just hello, then that's the only result you're getting. You do not necessarily know what's going on inside the method. And that is how we are hiding the implementation details of methods inside the container. From the outside, nobody can tell how the methods are actually implemented and how the logics actually work. They just use the method and they get the result. So that's what we're doing when we say that we make sure that no one from the outside of the container can tell how things inside the container work. And we use the method logic here to do that. We specify the method logic inside the container, and nobody from the outside of the container can tell how the method is working. They just use the method and they get the result. So you understand these three things. You also understand access modifiers because we used private here, right? And using access modifiers, we made sure that the container is not leaking any information and that it's not allowing any direct access for someone from outside of the container. Someone from the outside of the container does not have direct access to these variables. That's what we're doing with access modifiers by making this private. We can even have private methods, and those methods can be used inside the class. So you see how the person object behaves, how the person object is created, and what the person object has, and how you can interact with these variables, the things that the person has. All of this is being controlled inside the container. And nobody from the outside of the container can make unwanted changes. Nobody from the outside of the container can tell what's going on inside the container and how the logics work. And nobody can have direct access to the different variables. And so in this way, we are encapsulating everything that is important about an object inside the class. And this is encapsulation, making sure that everything related to a particular object's definition is perfectly controlled. But full encapsulation has not been achieved yet. There's still a lot of things that can leak. And we'll see a few examples of how still things can leak out. But I hope you now have a basic understanding of what encapsulation is.